والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا ونبينا محمد وعلى آله وصحبه أجمعين. Welcome to lecture number 10 in the psycholinguistics course. And before we talk about the perception or speech perception and lexical access, we will continue talking about the role of orthography. If you remember in lecture number 9, we stopped at the role of orthography. So is there any role of orthography in how we perceive sounds and how we classify them in our heads? Well, according to this theory, yes, there is a role of orthography. One might ask, first of all, what do we mean by orthography? Orthography of a language is its writing system, so including all the characters, the graphemes, and all of that. So what happens in reading? When you read, you match symbols with phonemes. Symbols with phoneme. So for example, this shape is or represents that sound. So in an experiment, in a research paper, they had two groups of speakers. First of all, native English speakers and Hebrew speakers. Of course, they were bilingual, English, Hebrew, bilinguals. And they gave them a deletion task. So what did they ask them to do in this deletion task? They were asked to delete the first phoneme in a monosyllabic word. So they would give them words like gun or but. And then we'll ask them to delete the first phoneme. Remember, phoneme, not sound, not letter. So we have English speakers and we have Hebrew speakers. The English speakers actually deleted the first sound, which is g, right? And they would say un. So they were asked to delete the first phoneme, so they said un instead of gun. Instead of saying but, they deleted the first sound and they said ut. Right? Now this is what the English speakers did. Now what about Hebrew speakers? In Hebrew, Hebrew is just like Arabic. For example, this is how we write but, for example, in Arabic. Right? But, maybe like that. So they asked them to delete the first phoneme, remember, phoneme, not letter. So what did the Hebrew speakers, what did they do? They deleted the first letter, not sound, and they said, instead of saying at, they said t. Because they deleted the first letter, ba, and they said t. Instead of saying un, they said n only. So gun, for example, if we write it with if we write it like that, gun, for example, the Hebrew speakers, just like Arabic speakers, would say n, whereas native speakers of English would say un or at. So there is a role of orthography. The way we write in Arabic or Hebrew makes a difference. It makes a difference to our perception of sounds and phonemes. Right? So the English speakers, because this is how the orthography works, the English speakers outperformed the Hebrew speakers because of L1 orthography, because of this difference in writing in English and Arabic and Hebrew. Right, now let's continue talking about accessing the lexicon. Now, as a speaker, if you want to say something, first of all, you access the lexicon, the words of a language, using information about what? About meaning. Then at the end, we have the phonological representation. If you remember from that diagram that I showed you, we start with the pre-verbal message. Then we have lexical access, we have syntax, then phonology. Now, in accessing the lexicon in perception, it's the other way around. We start with the phonological representations to get information about the meaning. That's very easy, by the way, and this explains it. In speech production, we go like this, right? We go like that. We start with the pre-verbal message, then we have lexical access, syntax, and then phonology. In speech perception, it's the other way around. We start with the signal. Obviously, it goes to the articulatory system or auditory system, sorry. And then we start with the phonological representation. Then, so basically we hear sounds. At this stage, these are not words. Maybe they're not yet lexical items. They're just sounds. Then we translate this phonological representation, this sound, to lexical items. Here, if it's the same word, or the same sentence, for example, the girl pets the dog. We hear it. We have phonemes, a lot of sounds. Then these are translated to words, broken down to words or lexical items, and we discuss the difference between words and lexical items. Lexical items are more, let's say, general. We have part of speech, we have information about this word, and we have the sounds it contains. So, for example, in the phonological presentation, they will go, okay, all right, so that's a word. Girl, pets, that's another word. The dog. So this is where it's broken down to words. Then we have the syntactic representation. So in the syntax, we know who did what. Who ate the apple? It's not the apple ate Ali, it's Ali ate the apple. So this is how the words are organized. So first of all, we have the phonological presentation. We hear it, we break it down to words, and then we try to make sense of it. Syntax. We try to know who did what. Once we are done with that, then the whole thing, this syntactic representation, is sent, well, to our cognitive system to create meaning. To create meaning. At this stage, this is not a pre-verbal message, it's a message. It's the message that we understand. Right. Now, lexical access, lexical retrieval here is really, really remarkable. It's very difficult, believe me. Why? Because now we are talking about the girl pets the dog. This is a small sentence. What about a whole lecture? You keep retrieving words. Maybe I say words that you say, well, I know the meaning of this word, but it's not frequent. I don't hear it a lot. But as I say it, you understand it straight away. Because this process takes place in less than a fraction of a second. It's very quick. So you have a very, very long, for example, language sample, very long speech, and then you retrieve words one by one, and then you send it to the syntax. It's a complicated process, isn't it? Phonology, lexical access, phonological, syntactic representation, and so on. Most people, I would say, know roughly 80,000 words. So a person with high school education would know 40,000 words. Add to them 40,000 words, let's say, proper names, school names, university names, streets, cities, all of that. So you retrieve one word from 80,000 words, roughly, in less than a fraction of a second. In no time, you retrieve it, and you send it to syntax. So you hear it first, and then you retrieve that lexical item, and then you send it to the syntax. Then the syntax would give you the meaning. So all of this takes place in less than a fraction of a second. But lexical access, accessing the lexicon, all of the words that you know in English are called a lexicon, just like a dictionary in your head. You open that dictionary, let's say, and you choose the word. So this is what I said. It's this word. It's this meaning. All right? Sometimes you hear a word that has 2 or 3 meanings, right? But you say, well, I know this person knows, this person wants to use this meaning, not the other. Why? Because you chose the word that means X, not Y. Right. So lexical access here. So let's say opening that dictionary in your head and saying, well, I think this person meant this word. This is affected by meaning and form relations among words, and by variables, this is important, such as phonotactics, word frequency, and lexical ambiguity. What does that mean? Remember, we are talking about lexical access. So how do we retrieve words? This is affected by meaning and form relations. We will talk about that in a minute. And by variables such as phonotactics. Phonotactics, what a language allows or does not allow phonologically. So for example, in Arabic, it is not allowed to have, for example, 3 or 4 consonant clusters. In Russian, they allow it. You can have consonant, 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 consonant in a word. In English, for example, we have texts. Texts, you know, if you check the sounds, the last 3 or 4 sounds are actually consonants, texts. But in Arabic, we can't have consonant, consonant, consonant at the end of words. This is called phonotactics. Arabic does not allow that, or Arabic allows this. Also, word frequency. How frequent is a word? Is it frequent? Do we use it much, or we don't use it much? And also lexical ambiguity. So how ambiguous is the meaning of this word? Now, one of you might say, do you have any evidence for what you are saying? I say yes. The scientific evidence that we have comes from lexical decision tasks. In this task, participants are briefly shown a string of letters. A string of letters, you know, A, B, C, D, or whatever. C, A, T, S, for example. String of letters. And then we ask them, is this a word or not a word? And we ask them to judge whether this is a word or not a word within 400 to 600 milliseconds. So ideally they will have a joystick, maybe like this, or a keyboard. And then we say, I'm going to show you a string of letters. If it's a word, press this button. If it's not a word, press this button. All right, then we start showing them the words. They keep saying yes, no, this is a word, this is not a word. In less than a fraction of a second, so 400 to 600 milliseconds only for each word. or non-word. And then the computer will calculate how long it took you to say yes, this is a word, or this is not a word. The computer will calculate. So for example, if I show you the word milk, and then you say yes, it's milk, it's a word, the computer will tell me that you responded in 200 milliseconds. Or when I showed you the word decision, it took you 600 milliseconds to answer yes, this is a word. Okay, so this is called lexical decision task. Now let's start this, of course, without this joystick. I just want you to take out a piece of paper just to try it out. All right, I'm going to show you few words or non-words. If it's a word, just put a mark here. If it's not, put a mark there. All right, I show you another word. Yes, it's a word. No, it's not a word. And go like that. All right, now I will start doing it, and I'm going to show you the words very, very quickly. So please do it quickly. Let's start doing the lexical decision task. Right. Now you should calculate how many words do you have as words and how many as non-words. Just count how many words and how many non-words you have. And by the way, in the real task, this is how the words are going to be shown. They are going to be shown like that. So quicker than I showed you, but I just wanted to give you an idea. Right. So in lexical decision tasks, participants will be shown or will see equal amounts of words and non-words. So 8 words and 8 non-words. Just string of letters. Now, if you look at tlat, zner, and mrok, all of them are non-words. Also, skern, plem, and flub, they are also non-words. So all of them, 1, 2, 3, 4, 5, 6. We have 6 non-words. But remember that I said the computer will calculate how long it took you to say, yes, this is a word or this is not a word. Now, participants, all of them said these are not words, which is correct. These are not words. But the interesting thing is that we have quicker responses to these words than these words. So quicker here. It's very fast. They, as when you show these words to the participants, they say, no, these are not words, straight away. But with these words, participants take longer. Why? The answer is, these words violate English phonotactics. Remember that I said phonotactics influences or affects lexical access. So now as you access the lexicon, checking whether your mental lexicon has these words, your brain will say, no, these are not words, straight away. Why? Because they don't sound like English words. Znr, tlat, mrok, these are not English words. And they don't sound like English words. So they violate the phonological rules of English. And that's why native speakers would say, no, these are not words, straight away, very quickly. But with these words, skern, plem, and flup, they are non-words, but they don't violate the phonology of English. So we call these possible non-words. So what is possible non-words? They are non-words, but they don't violate the English phonotactics. They are possible non-words. But these ones here, they are impossible non-words. They are non-words, and they cannot be English words. They are impossible non-words, phonologically. So, phonologically, these words are impossible. They are non-words, and they are impossible. They cannot be English words. So we call them impossible non-words. These here are non-words, but they can be phonologically non-words. They can be English words. So overall, we have quicker responses to tlat, znr, and brok. We reject them straight away because they don't sound like English words. But with these words, we take a little bit longer, just a little bit longer. We say, no, this is not a word. But it takes us time to reject it. All right, so they are impossible non-words, the first ones. Now, also, what we found is that there are faster responses to words like clock and bank. So quickly, very quickly, we say, yes, this is a word. When you say clock, say, yes, this is a word. Bank, yes, this is a word. But when you say hot or earn, it takes us a little bit longer to say, yes, these are words. These are English words. Now, hot and earn are words, all right? They are not non-words. They are correct English words. Hot, as in Pizza Hut, for example. Earn, an example of earn, when someone, for example, dies in some countries, they burn the body and they put the ashes in an urn. This is called urn. So it's not frequent, is it? Hut. Nowadays, we don't say I'm going to my hut, for example. We say I'm going to my house or my flat or whatever, my villa, things like that. So the word hut is not that frequent. Earn is not that frequent also. But bank and clock are frequent. And that's why when we see a word like clock, we say, yes, this is a word. Bank, yes, this is a word. Earn, yes, it's a word. But it takes us longer to say, yes, this is a word. Hut, yes, this is a word. So it takes us a little bit longer here, but faster here. Why? Because frequency plays a role in lexical access. So if it's a frequent word, a word that you hear a lot, you will retrieve it faster. than words that you don't use much. Now, probably we know that, but this is the evidence. We have scientific evidence in milliseconds. Remember that in this task, we have computer measuring how long it took us to say, yes, this is a word or this is not a word. Yeah, so one might say, how do we measure the frequency of items, the frequency of lexical items? We have something that is called corpus. Corpus is a large sample of the language. We have the British National Corpus, for example, which contains around 450 million English words or English texts. So TV interviews, the scripts of the news, everything that is said on TV, everything that is published in English, they put it together and they count how many times each word appeared. How many times each word appeared. And this is how they measure the frequency of words. All right, lexical ambiguity also plays an important role. So, ambiguous is not clear. Ambiguous words. Right, let's take this example. The word bank has many meanings. It can be, where you keep your money. It could be the river bank. When you have a river, you have two banks. Snow bank also, when it snows, you have a bank. All right? So we have many meanings for the same word. We either have homonyms or polysemous words. Homonyms and polysemous words. Homonyms, when you have words like left, the past tense of leave is left. And also you have left as an opposite of right. Opposite of right is left. The past tense of leave is left. It's the same spelling, isn't it? This is called homonyms. Homonyms. Now, is it the same meaning or different meanings? Of course, it's different meanings. This is left, a verb. This is noun. Opposite of right is left. So different meanings. Homonyms. Polysemous words, when you have the word mouth, for example, you can say, this is my mouth, or this is the mouth of the river. This is where it flows. So the mouth of a river, or the mouth of a person. More or less, it's the same meaning, isn't it? It's the same when you say eye. You know the needle that we use it for sewing, for example? We say there's the eye of the needle. This is where you get the thread N. The needle, you have an eye. We say this is the eye of the needle. This is similar to the eye, the idea of eye as a body part. So this is called polysemy, polysemous words. Now, what researchers found is that polysemous words, things like the eye of the needle or my eye, are retrieved faster. They are retrieved faster than homonymous words. Homonymous words which have different meanings. Take the word punch, for example. Punch, you can use it as a verb to punch someone on the face, for example, or you can have a fruit punch and you drink it. Two different meanings. They are unrelated. And that's why it takes us a little bit longer to retrieve words like this than words like eye, the eye of the needle, or my eye, for example. So it takes us, it's quicker for us to retrieve eye or the mouth because it's because they are polysemous words. So they are, close in meaning, let's say. Close in meaning. But homonyms, no. Two different meanings. Let's say homonyms equals competing meanings. We have 3 or 4 meanings competing, and then we choose one of them. But when it's polysemy, it's the same meaning, more or less. So we retrieve it faster. Now, the last point that I want to talk about in this lecture is called priming. In perception, in how fast we retrieve words, we have something that is called priming. Now, if I say, for example, the word, whatever, anyhow, for example, maybe in the last 1 year, you haven't said the word, or you haven't used the word anyhow. But maybe because I use it a lot in this lecture, maybe tomorrow or today you will start using this word. This is called priming. I primed you to say that word. And notice that in any conversation, when you have conversations with anyone, if one of the interlocutors uses a form, a word, the other person will start using that word as well. So, a stimulus you just experienced, heard, or produced will affect how you respond to a later stimulus. And this associative response is true not just with linguistic stimuli, but also with stimuli of any type. So pictures, smells, non-linguistic words, and so ever. So basically what you need to know is that when you hear a word, that will also affect how you respond to similar words. Okay, let's look at an example. You remember this task that I showed you, this one here? Now I show you a word and then I show you another word, right? Sometimes we say that this word primes this word. It makes a difference. Let's look at this example. For example, here I show you the word doctor, then I show you the word nurse. You see? Now we say the word doctor primes the word nurse. And I'm going to show you the effect. So here, the word that I show you before is called prime. This one here. So first of all, I show you the word nurse. And I show it to you in 500 milliseconds. And then it disappears. And then I show you the word doctor. Now, do you think the word nurse is related in meaning to the word doctor? Yes or no? Yes. Nurse, doctor, hospital, student, teacher, school, fail, pass, things like that. So they are related primes. So this is called prime because I showed it first. And my target is doctor. I will see how long it takes you to say, yes, doctor is a word. So first of all, I show you the word nurse. Is it a word or not? You say, yes, it's a word. And then I show you the word doctor, and you say, yes, it's a word. I want to see the word doctor. How long it takes you to say, yes, this is a word, if it is preceded by a related word. Like here, nurse. I count how long it took you to say doctor here is a word. Maybe, let's say, 200 milliseconds. You said, yes, this is a word. Then I show other students or Other people? First of all, an unrelated prime. I show them the word cabin, which is not related to doctor, is it? Okay, they say cabin, yes, it's a word. And then I show them the word doctor. What we found is that people takes them, it takes people longer to say this is a word. They say maybe 400 milliseconds. Why? Because here the word doctor was preceded by an unrelated word, unrelated prime. And that's why it takes people longer to say, yes, this is a doctor, this is a word. It takes them 400 milliseconds here. But here, because I show a related word, nurse, doctor, so when I say the word nurse, your brain brings all the words that are related to the word nurse closer for retrieval. And that's why when you show nurse, hospital, yes, it's already in your head. But when you say nurse, car, it takes your brain longer to say, yes, car is a word. And things like that. So this is called priming. So here we have a related prime, nurse, then I show you the word doctor. People say, yes, it's a word in 200 milliseconds, very quickly. Here I say the word cabin, then doctor. And it takes people 400 milliseconds to say, yes, this is a doctor. This is a word. So what we see here is an effect of priming. If I use a word, usually your brain will bring together, will remember all the words that are associated with this word. Nurse, doctor, hospital, operation, things like that. Alright, so responses to the target will be faster when it's preceded by a related than unrelated prime. So priming activates associates. Any words that is associated with this word. Alright, I hope that this is clear now. Alright, I think that's it for today's lecture. That should be enough. Please go back to that section on lexical decision tasks and priming. And by next week, hopefully, the content, the whole summary will be available for you for reading. Please read that section. Make sure that you understand lexical decision tasks and what they mean. Impossible words, possible non-words, possible non-words, and impossible non-words. What do we mean by each? Also priming. What do we mean by priming? And what difference does it make? If I show you a word that is related or unrelated, then I show you a prime, like the word doctor. Thank you very much for your attention and for watching this lecture. And see you, inshallah, in lecture number 11. Assalamu alaikum.